Hello stats students, let's take a look at a few things to review for the Chapter 12 tests. So I'd like to start with the following. These are 6 multiple choice here. Your options are A, B, and C, so for each thing that describes. So if I were to plot just the variables x and y and I found that that was about linear, which of these would be true? Would it be a power model, an exponential model, or none of these? And then if I plotted x to the power of p versus the response variable y, and that appeared linear, which of these would be true, and so on for all 6 of these. So take a second, or I guess a minute or two, write down your answers for all 6 of those, and then when you're ready to check your answers, go ahead and press play. Alright, let's take a look at what you got. Starting with number 1, that would be none of these. If that's linear, that would just be a linear model. Number 2 here, if that's linear, then it is a power model. Number 3 here, if that appears linear, then it's called a power model. For number 4, if x plotted against the log of y is linear, that is called an exponential model. That's the one way to check to see if an exponential model would be appropriate. Now, there was no time that we've done log of x compared to y, so that would be none of these. In fact, that would be a logarithmic model, which we do not cover in this course, so that type of transformation is not our test. And then finally, if you plot log x versus log y and that's linear, that is called a power model. So there you go, and that goes back to these ways to test. 3 different ways to test a power model, and 1 way to test to see if something is an exponential model. Alright, the next thing I'd like to do is take a look at this output table. So this is the output table for the data that was the IQ versus cry count. So it was measuring how often a baby cried and compared it to their later IQ, and these were the results from a linear regression analysis. So what we're going to do is we're going to talk about which of these numbers you should know and be able to interpret. So we're going to go kind of one thing at a time here and take a look at each of these. So if you want to copy down this table, and then what I'm going to do here is for each one of these numbers, we're going to describe what it means. So let's start with this red number here. This number is called the y-intercept of the regression model. It's the predict. It's hard to write with the mouse. Okay, it's the predicted y, or in this case IQ, if x, or cry count, is 0. So it's what we would predict an IQ score for a baby if we measured no crying. Next number here is this green one right here. This is the slope of the line, and it's the predicted change in y if x increases by 1. So for this data, it would be the predicted change in IQ if the cry count increases by 1. Next, that blue number there is S. That's called the standard deviation of the residuals. And what that number means is, using this model, our predicted IQs will typically be off by 17.5. That's how you can interpret standard deviation of the residuals. And then that purple number there is R squared. That's called R squared. And that means 20.7% of the variation in y, or IQ, is accounted for by the regression line. That's how you interpret R squared. Next up is this number right here. Okay, that is the SE sub b. That is the standard error of the slope. Now what that number means is if we repeated many samples from a population, the slopes of the sample regression lines would typically vary by 0.4870 from the slope of the true regression line of the population. Alright, and then the next number we're going to look at is this number right here, 3.07. You can see that's under the letter T, and that is the test statistic. Now, what a test statistic does in general is it measures the number of standard deviations above or below the assumed value. In this case, the assumed value would be 0. And then the last one we should know is this number on the end here, under the letter P, is a p-value. Okay, so this is a picture of the p-value from the test statistics, so that's what those two numbers mean. Now that's the p-value of a two-tailed test, which is 0.004, which means the area of just one tail would be half of that. So you have to pay attention to whether you're doing a not equals test or a greater than less than test. So you might need to cut that in half, depending on which type of test you're doing. Now, to interpret a p-value, just a reminder, it's a conditional probability. The condition is if the null hypothesis is true. In this case, for the output table we're looking at, the null hypothesis would be that the slope is 0, which means that there's no relationship between the two variables. So for this type of data, or for this output table, the condition, the null hypothesis, would be if there's actually no relationship between the two variables. So there's not a linear relationship. That means slope is 0. Then the probability of getting a result this extreme is 0.002. So that's how you interpret p-value. So there's all the numbers you should know. You'll notice there's a few of these that I didn't discuss. That's because we don't need to know these. You could probably guess what they are. They are related. These ones are all related to if you're doing inference about the y-intercept, which for this course we do not do. So we're never going to use those three numbers. And this r-squared adjusted we're also not going to be using. So there you go. Next thing you should do, to review for the test, read those section summaries that I always recommend, and work on that AP Stats practice test at the end of the chapter. So, and please, of course, let me know if you have any questions.